I guess I should translate the title first. It's basically our experience implementing well, a dashboard utilizing Cassandra and various other technologies. I'm Robert Johnson. I'm a senior software engineer at Vertafore. I've been there for 5 years, and I've been a developer for about 10. The project we've been working on, we have been working on for about 9 months, and then we released it to production just a few months ago. So we've had a fairly quick development cycle on this solution. So a little bit of background on who Vertafore is. We are a leading software provider for the insurance space. We provide software for insurance companies, which tend to be on the conservative side of change. So Vertafore aims to help them serve their customers better by utilizing the latest technologies. So Vertafore is a growing company with plenty of opportunities. It's a company of about 1,200 employees with deep domain expertise. A third of those are developers providing applications for our insurance companies. We provide software for over 300,000 professionals who use Vertafore software on a daily basis. Software that touches all the areas of the insurance industry. So we've got soft products ranging from client portals, providing access for individuals to get their claims and policies. We've got rating systems. But our primary software is around agency management systems for the agencies to track the policies and invoices and all the daily business of an insurance company. We do have multiple agency management systems in our Vertafore ecosystem to scale from both large agencies and small agencies and most things in between. So that leads us to our problem space, where agencies can have a big mix of these agency systems. And one of the goals of our dashboard is to be able to provide data, or aggregated data, for reporting on how the business is doing across multiple systems. So we first need to collect that data, some of it being hosted on-premise environments as well as hosted. Some systems, or some agencies, have multiple systems from acquisitions and mergers, and we need to be able to provide rules on how they aggregate data from one system to another based off of whatever the configurations of that individual instance were. They also need to configure how these systems will interact with each other, and we collect all that data and present it on a dashboard where we need to support very strict SLAs. Providing the data in less than 250 milliseconds was our stated SLA. On the bright side, since we're utilizing Cassandra, we've seen most of our requests are responding within 10 milliseconds, so we're well under our SLAs there. The other points of concern where we have an unknown scalability question, where our first product where we built the dashboard for has itself 400 agencies as possible customers for this project. And as we add the ability to provide data for more systems, the scale is not something we can easily predict. So we've got unknown scalability concerns and quick response times. The obvious for our technologies are aiming towards technologies that tend towards scale. And we're obviously at the Cassandra conference, so we decided to use Cassandra to fulfill the back-end data needs of our application. We are utilizing a number of other technologies around process management and queuing. One of the words there, autonomous, is quite a word to say. It's a .NET library for managing state machines and message processing in association with mass transit. They say hindsight is 20/20 vision, and after learning some things from after we've implemented most of this, there could be some other possible solutions utilizing Spark and a number of these other technologies we've seen here. But Vertafore is new to Cassandra, so we're limiting the number of new things we implement at the same time. Stick with a mix of things you know and things you're learning. So we mentioned protocol buffers there, which is a serialization schema from Google. And one of the things we found early on in our planning phases was they handed us 12 gigabytes of XML data and says, these are the sorts of things we need to be collecting from these systems. And as we're pulling from on-premise systems into a hosted solution, uploading 12 gigabytes of data from 400 agencies is not something that is easy to look at. So we played with the data a bit, utilizing Google protocol buffers to serialize this data. And after serializing it and filtering it and compressing it, we got down to about 100 megabytes of data that we were actually interested in, that 12 gigabytes of data. So how do we put all these technologies together? Here's a architectural diagram. We have in the bottom right agents that are hosted by the source systems that will collect data from that system and package it up and send it to our services in our hosted environments. That can either be an initial load of data, which will load the historical values we will need to provide dashboard aggregations, as well as after they've performed that initial upload, they can just send us deltas of what changed since the last upload. We have a configuration management endpoint that lets the agency administrators configure how aggregation of their data works. As I mentioned, there's possible situations where they'll have multiple systems in a single agency, and we need to be able to aggregate across those systems, even if those systems don't know about each other. So we're utilizing queuing systems as most of our processing is event-driven. So when the agency uploads data, that'll trigger events in our system that will end up processing that data and triggering more events. As we have a state machine, we can transition from one state to another. That makes the maintenance of this system really easy. Has been one of the side effects we've seen. Something that we did run into fairly early in regards to serializing a state machine in Cassandra is we found that we needed to utilize quorum consistency on most of our reads and writes on those state machine properties, as we wanted to make sure we were getting the latest changes to the state of the state machine as it transitions from one state to another, and the various properties we serialize throughout the processing of our data. We found that utilizing quorum consistency solved a lot of our potential concurrence issues. The primary point that we'll start with here is the dashboard itself, where we needed the high SLAs and the good performance. So we've got an example of some of the dashboard data that we present to our customers here. The primary thing here, or at least some of the quick data they get at the top, is a dashboard that shows comparisons of their data between the current year and the equivalent point in time for the previous year, so they can see at a glance whether they're doing better or worse along those metrics for the current point in time. So each tile has a corresponding panel which will present more in-depth data. So as we see here, we've got a net agency revenue over a 24-month period, with the 24 months being side by side, so they can look at this June compared to the previous June. Other metrics like new and lost business to give them indicators of how their sales pipeline is doing. And we've got total transaction totals and a payee total, so they can see at a high level which carriers are driving most of their business. These are all metrics that an insurance company would be interested in knowing. So this is an example of the data we anticipated needing to provide. And since it's a web application, obviously they're going to like things in JavaScript. So this is an example of one of the endpoints. So since we're providing JSON, we're a .NET shop, so we are utilizing ASP or .NET Web API references. More specifically, we're also utilizing a technology called OData that helps provide discoverability on top of a RESTful endpoint. We're using standard patterns of dependency injection and repositories to abstract out our data calls from our web interfaces. And our repositories are basically wrappers around the Cassandra data. Here's an example of one of our tables where we partition the data for a particular data set. So one of the interesting things that we were considering when developing this is we didn't want to change the dashboard without the user's knowledge. So if they had a new piece of data come in and they were in the middle of analyzing something, it's not a good idea to change what they're analyzing in real time necessarily. We want to let them be aware of the changes there. So we track all of their data according to a data set. The data table here closely reflects what we're returning to JSON, so there's minimal transformation happening, which helps provide the fast response times. Our summaries are just the comparison data for this year versus the same point last year. And then we have a list of values that, should we need to provide longer term data, we can just extend the values on this list without requiring a change to schema. Where do we get this set ID, since it's pretty obvious if you're looking at a Cassandra table what your queries are going to be. We're keyed off that set ID, which the clients need to provide. So we have the concept of a data group, so they can configure what their dashboards are. They can have multiple dashboards for different views of data, and that's all tied through the identity of the user. So we can be sure we're partitioning and securing the data so we're not showing an agency data that doesn't belong to them. And again, we're utilizing the same patterns, simple REST calls into a database. So we put an index on our single sign-on identity IDs to get the data for a particular customer, and that will give us a set ID unique to each group of data. This table is mostly static, except for the set IDs will get updated as we get new data for them. This triggers the UI to know when changes occur, so they can present update notifications if so desired. Okay, so now we have a set of tables that we're providing to the dashboard to give these high SLAs and fast performance. As I mentioned, we're utilizing a state machine. Here's the primary states of our state machine. They get triggered by various events. So uploading data triggers processes that will validate and store that data. And then as we're aiming towards providing data for a dashboard, we have a few aggregation steps where we aggregate the data to some internal forms, which takes care of a number of the cross-system compatibility issues where one system has a completely different structure for what a policy is than the other systems, and we unify all the data schema to the internal forms here. And then during our finalization phase, where we're denormalizing the data that was then collected into each of those dashboard tables. So each dashboard graph is backed by a special table. Well, one of the things we learned earlier on in Cassandra is describe your queries first, and then you can work backwards from there. So you know what data you're building and how you're going to be querying it, and that will describe the tables that you need to populate that. And then a little bit more in depth here. Here's some of the processes that happen during each of those steps. As I mentioned, upload is triggered by batch start. Data upload is handled in batches. So these batches can either be a full set of data, meaning it's the first time that particular system has sent data to the aggregation layer here, in which case that's going to be the large historical data sets that can be 100 megabytes big for a given agency. We want to make sure that we do a good amount of data validation, make sure that the stuff that's being uploaded matches with what we expect to do with it. As we have control over both the source systems and the aggregation process, this is a useful thing for us to do. We found that storing this data basically as it is uploaded, it has been a useful way of saving space on the data uploads. So we just store a reference to what the data that was uploaded and store it on disk for later use. As I mentioned, we do have the intermediate data. So during our preparation phase, we all through the events of the queue and the state machine, we load that data and apply the configuration rules. So the general case of the configuration rules is when they're building out what counts as new business for an agency, and since it can be different from one instance of an agency to another, the configurations are basically filtering what data gets used. And then after those filters are done, we store the filtered and unified data into an intermediate table. So the processed data that is in the intermediate form is what we utilize for generating the data in the dashboards. So here's an example of the intermediate table. A couple of the key points here is, as mentioned, we have groups of configurations, which defines the rules for how this data was configured, what values got included in it, and it also corresponds to the dashboard data. The batch ID is representative of the batch of data that this instance of data started from. Because as mentioned, should they reconfigure or change the rules of configuration, we need to go and reprocess the data and generate it for a new configuration. The interesting point here is we serialize the data for the values of the individual days of the month in a blob. And specifically speaking, that's another use of the protocol, Google protocol buffers, where we serialize the daily data in a structure that is known to our application. Some of the other pros of protocol buffers is we can manage the schema changes and change the serialization data with relative ease, as that's some of the built-in things to how protocol buffers serializes its data. So the other things there is it optimizes the network transmissions. So we know that we're going to be selecting a large chunk of these pre-aggregated data forms when we're doing our processing of it into the final form. So we serialize the data and utilize Cassandra streaming to efficiently grab large chunks of data to be processed. So when we, sequential reads. So our overall experiences here have been pretty good. As mentioned, we were able to implement this within 9 months. Some of the big selling points of why we chose Cassandra is we like the no single point of failure in the architecture of Cassandra. We found that conflicts with some of the traditional ways of thinking in our DevOps environments where they have ideas of how they want to deploy things, but the way Cassandra does it is architected to fill all those needs from the beginning. And the other reason why we wanted to use Cassandra is the ability to support unknown scale, where we don't have to worry about it. When talking to other developers, they'll often ask me, okay, how's your database scale when choosing another solution? And I'm like, well, I don't have to worry about that because I chose Cassandra. Or it's not a big concern. So as to some of the things that we would like to see better improved is the development tools around Cassandra are fairly minimal. The DataStack's DevOps Center is rather limited in the sort of dev tools you can use it for. And perhaps the more annoying one is we haven't found any good tools for schema migration and deployment management for managing the schemas. That's still mostly a manual process at this point, but I expect we'll get to some sort of solution to that sooner or later. Actually, there was one other point here. So, as Vertafore is new to these sorts of technologies, we want to have incremental improvements as how we do things. So it was suggested from upper management that we try to see if we can use Cassandra here, because as with many businesses, you want to limit the risk of new things, and so doing, as I mentioned in the beginning, doing one new thing at a time is a good way to slowly build up your domain expertise in new technologies. So moving forward, some of the things we expect to support in future versions of our dashboard is additional levels of detail, which will require sorting and filtering of the data at the dashboard level so they can get more fine-grained views of their data. We anticipate utilizing Solar search to support most of that filtering, as that's a good pairing for distributed filtering and searching. Further down the road, when we add additional service systems to our aggregation process, that's where the scalability concerns will become more apparent, where we need to support our other agency management system that has thousands of servers deployed, and being able to support the load from all that is something we'll need to validate and probably start scaling out our Cassandra nodes. I think I went a little bit quick, but I got about 10 minutes for questions.
Thank you. I have a couple of questions. For the visualization, do you actually do your own visualization, or you have a third-party software to do it? And second question is, like, how do you put the data from Cassandra to the dashboard?
That's what the REST API does. So the first question, we have a UI team that's built the UI for our presentation. There has been look into, I don't remember the name of it, but there was a third-party aggregation visualization tool that we've been investigating at Vertafore, and tying what we've done with our services into that is something that we are looking into. As to the second question, how we get the data from Cassandra to the dashboard is through those simple REST services that I presented. It's simple queries, just selecting the data for a particular data set / customer.